Every year, the world produces around 70 million tons of PET plastic. This is the plastic that's in your food containers, water bottles, and even clothing. Although less than 10% of it gets recycled every single year, this traditional recycling method has many issues. What is traditional recycling? It's when you melt down and reshape the plastic, but each time you do that, the polymer chains get shorter and weaker. The material degrades. That's why a water bottle might become a park bench, then a carpet fiber, and then nothing. It's not truly a cycle, but rather a slow decline. In 2016, researchers in Japan found something interesting at a recycling plant in Osaka. A bacterium, which they called Iodinocyanus, had evolved the ability to break down the PET plastic. It produced two enzymes that worked really well together. PETase and METase. PETase cut the polymer chains, then METase finished the job, releasing its original building blocks, terephthalic acid and ethylene glycol. It was the first known organism that could fully break down the PET plastic into its starting materials. The natural enzyme was slow, taking weeks to break down a thin plastic film, so researchers started to improve it. A French team used computer modeling and protein engineering to optimize the enzyme structure. The modified version achieved a 90% breakdown of PET in just 10 hours. This had one key advantage. They were recovering the original monomers, which then they could use to make new plastic that was chemically identical to the virgin material. It was not downcycling, it was true recycling. So where are we now? In 2025, economic analysis shows that it's more than a lab trick, and it's actually becoming cost competitive with making virgin plastic from oil, comparing $1.51 to $1.87 per kilogram. Additionally, a company called Carbios just opened the world's first industrial enzymatic recycling plant in France. It plans to process 50 tons of plastic waste per year, which is around 2 billion bottles. The journey from a Japanese recycling plant to global factories took less than a decade. However, challenges remain with crystalline plastics that are harder to break down and scaling up the enzymatic production. It's still expensive. However, it uses up 80% less energy and cuts the emissions by nearly half. It's truly amazing to see how advances in chemistry can not only lead to a more sustainable Earth, but also economically more salvageable.